Hi, my name is Andre, and I'm here to talk to you about our project, which consists of growing plants under different conditions, such as under an electric field and under a magnetic field. I'm planning to go into electricity and magnetism, so this sort of relates to what I like doing, and this seemed like an interesting project to test. If you connect them to a battery, the potential difference will create an electric field between the two plates. So that's essentially what we put in the soil, and we put the seed in between the two plates, and this was supposed to generate.
Just to sort of mock up the setup, it would sort of have looked like this. And what happened is that the seeds did not grow. And we're not sure if it was poor control, because this is actually metal that has voltage on it going through it, like touching our soil, or if it was actually because of the electric field. So we need to do another experiment to actually control for these variables that we might not have been testing for.
As you can see in the diagram, we're going to shine a blue UV light onto the plant leaf, which is then the plant itself will absorb the light and then re-emit light in the red-orange spectrum. And we're going to detect that using an optical detector, and we're going to filter out all light that is not orange-red, so we can only measure the orange-red light. And we're going to get a graph that looks sort of like this, where this is the intensity of light with time. So at first we're going to flash it with a sudden burst of light that's going to get the intensity very, very high. And then we're going to close the high intensity light and put a lower intensity light, which is going to slowly make the plant leaf decay, and then we're going to flash it again, and we're going to get a curve like this. And measuring the peaks and the minimums, we're going to calculate how well the plant has grown and how well it can carry out photosynthesis. So this is a red light filter that only lets pass the red light, which is the light we want from the plant. And then this is connected to the computer, and it detects light, and here we can see this is voltage and this is light intensity, and this measures both of those. And since we put the filter on the measuring, it only measures it for red light, which is what we want.
Which is what we're looking for. So.
And the rest of the circuit is basically just two LEDs, two blue LEDs connected to a power supply. This was our first flash.
That's the first pulse, and then we turn on the other light, which you can see is a little higher than before, and then we waited for it to go down a bit before we let it flash again. The idea is the difference between this height and that height and this height and that height. They're all related in such a way that we can actually infer upon the health of the plant.
We get to learn about how electric and magnetic fields affect life, and that could be very useful information for us because we're living beings.
It's just nowadays we're just surrounded by electricity and magnetism, so if it does have an effect on life, maybe it could indicate that it affects life elsewhere. What I found like the most interesting about this is that when we actually do get together and we actually start looking at these problems and we start talking about these equations, and it's all like, oh, look at this, and then he sort of starts guiding us to these, sort of start pushing the boundaries of what we know. I think that's what sort of got me interested, is that it's not a course, but if you treat it as though it was a course, you can benefit from it. Like, it's just a chance to apply what we're learning, I guess. And I guess that's just, it's a nice reassurance, because it's like what we're learning is useful, and like we can do things with it.
And we also get to collaborate with other people who are interested in the subject. So that's a big benefit.